Hello and welcome back to another one of these aiming for a grade 9 practice papers, this time for 2023, released by Pearson themselves. And this time I'm going to do paper 2. So I wanted to release it closer to the actual paper 2 exam, but then I realised that doesn't really make 100% sense, considering any topic can come up on any paper, so we may as well get them all done as soon as humanly possible. So without further ado, let's get started. It's a calculator paper, so we are 100% going to use that. And it says here, solve this quadratic. Calculator paper makes me think of the good old-fashioned quadratic formula. Minus b plus or minus the square root b squared minus 4ac all over 2a, where a is just equal to the number in front of x squared, 6, b is equal to 5, and c is equal to negative 6. So let's do it, and we should get two different values, one for the plus version, one for the negative. So let's do it. And you might notice that I do something which I continuously tell people to do, but they don't seem to do it. I put all of my values in brackets because it avoids any possible errors, okay? And believe me, even sixth formers make errors on this, which is really frustrating to me. A is 6, C is minus 6. So with these minuses and things like that, it just kind of prevents anything naughty happening. And, whoops, not 12. Times 6. So first value is 2/3, so we're going to say 2/3, and x is equal to, so that's the plus version, as you can see in the top right here. So now what we're going to do is change that to a minus version, which is minus 3 over 2. Those are our two values, 3 marks, nice and easy, hopefully. Okay, so Aaliyah bought a car. In the first year she bought the car, it depreciated by 23% per annum. In the second year after she bought the car, its value depreciated by 19% per annum. At the end of the second year, the car was worth £10,914.75. Okay, so the way I would do this is I'd say in the first year, the original value x was multiplied by 23% decrease. So if it's a 23% decrease, that means we do 100 minus 23, which is 77% of its original value. So it's done x times 77%. And that's given us some value, right? Which we can call y for now if we want. Then in the second year, it depreciated by a further 19%. So 19% decrease means it's a 100 minus 19. It means it's now at 81% of its starting value. And that equals 10,914.75. So what we can do is just work our way backwards now. Now I will say that there's actually a way to do this all in one step, but I'm not going to show you it. But what I am going to show you is a neat little trick. So y here is just going to be equal to 10,914.75, and a lot of your teachers probably tell you that you need to change the percentage to like a decimal or something. But I'm going to show you that you actually don't in a calculator exam, because if you just enter this in normally, so 10,914.75, 81, there's a big percentage button on your calculator right over here. So that's shift answer. It automatically does it all for you. You don't need to do it. So y is equal to 13,475. And if you remember, we can sub that into here. That means x is equal to y, which is 13,475, divided by 77%. Okay. Just so you're aware, this is 1 mark, this second step is another mark, and the answer is the third mark. But again, if you kind of get it right, it doesn't matter. So answer over 77%. £17,500 as the answer. Cool, and that is the third mark right there. And for the first part, by the way, the mark comes from substituting into the quadratic formula and then the two answers. Nice and easy. I will link this paper and mark scheme in the description as well. A and B are points on a centimetre grid. A is coordinates minus 7, 6. B is 8 and minus 5. So what I'm going to do is I'm just going to write out. So we have this is up here, and then all the way to the right and further down we have point B. And that is 8 minus 5. This is minus 7, 6. We need to work out the distance. So we're working out this distance here. Now, there's a few ways to do it. There is a formula that you can memorize. which is just the difference in the y values squared plus the difference in the x values squared, square rooted, which you're more than welcome to do. So in short, it would be this. The difference in y values, so minus 5 minus 6 squared plus minus 7 minus 8 squared, right? Difference in y and difference in x squared added together. That will give you the right answer, don't worry about it. But it's a somewhat tricky equation to remember if you don't see where it comes from. Where it comes from is if I kind of make this dot 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 into here, right? This is a big right-angled triangle. This is actually just Pythagoras. So if you look at this vertical side, the height of that is going to be the difference in the y values, 6 and minus 5. So 6 minus minus 5, you have a calculator, but it's just 11. And the bottom side is just the difference in the x values, which is 8 minus minus 7. 8 minus minus 7, which is going to be 15. So in short, this length AB here is just equal to square root 11 squared plus 15 squared. Because again, that's just Pythagoras' theorem. Both of those will give you the exact same answer. It's just that in the mark scheme, I imagine it's written like this as well. But a lot of mark schemes and explanations will just show you this equation. But in my opinion, it doesn't make sense unless you've seen where it comes from. Now I can see this is actually Pythagoras and this is just the difference in y and the difference in x. Cool, right? But before that, it's hard to see. So I thought that might be a slightly easier way to show you it. I mean, root 346, which in other words, it says to one decimal place, it's 18.6 centimeters. To one decimal place, in brackets. Nice. Hey. Back to some circle theorems. I love circle theorems. Okay, cool. So A, B, C, and D are points on the circumference of a circle centre O. A, D, E, and B, C, E, yeah, they're both straight lines. They're not tangents. We need to work out the sides of the angle C, D, E. So C, D, E, that is this one over here. Okay, so let's have a think about what we can do. Okay, so, I've had a little look. So this is a triangle, so we're probably going to use that, you know, because 16 degrees is here, we're going to have to use that at some point. It means we're probably going to need to work out this angle and then do 180 minus 16 minus this gives us that. Okay, cool. So the first thing I've noticed, and this is something I spotted immediately, is that this angle here is half this angle here, right? So that'd be 66 degrees. Why? Because if you look, they're created from the same 2 points on the circumference, D and B. Angles at the, so it says give a reason for each stage. So what we have to do is say angles at the centre, half at the circumference, right? Well, actually in this case, I've written it the wrong way around, so it'd be double, twice. Centre twice at the circumference. So please forgive me for my caveman writing. You should probably write this out a bit neater. Yeah, that's 66. And then if you notice, now I have this angle, the next thing I notice is that all four corners are on the kind of circumference of the circle, which means this is a big cyclic quadrilateral, which means this angle here, right, is opposite the angle we've just worked out, 66. And if you remember, opposite angles in a cyclic quadrilateral add to 180. So in other words, that angle BCD is just equal to 180 minus 66. Okay? Which is 114 degrees. Cool. And just like I said, we're probably going to have to work out this angle and then do the angles in a triangle add up to 180. So this angle here. And by the way, we actually don't really need to give that many reasons, but I'm going to give reasons for each step entirely. But we get 180 minus 114, which equals 66 degrees, right? Angles on a straight line add up to 180. So then the angle at D, so CDE, is just equal to 180 minus 66 minus 16, right? So that would be, you know what, screw it, let's just use a calculator. 180 minus 66 minus 16 gives me 98 degrees. And again, the reason for this stage over here is that angles on a straight line add up to 180. This stage here, angles in a triangle add up to 180. And that gives me 4 marks. Okay, we're making good progress. Okay, diagram shows 2 similar solid triangular prisms. The volume, good lord, that's a hideous number. Cross section is this. Okay, cool. 4B, the length is 8.1, and the area is this. The height of the triangle is here. Is that okay? Work out the value of h. Okay. So, what I'm looking at here, and this I believe is what we should be doing, is immediately, if it says I need to work out the height here, that means I need the height scale factor. So at the moment we have the volume scale factor. So for volume, if we have A to B, we have 2 hideous numbers. 1,587.762. Ugh. So that means the height would just be the cube root of both of those numbers. So cube root both of them. So that's shift and then the square root button. 58.80. Whoops, not 2 zeros. 6. 3. God's sake. All right. It's probably best to do this to 3 decimal places, right? Because that's what the other ones are. To be fair, it's not going to make much difference to our actual answer. So 3.88. Actually, there's an even easier way to do this. Just thought of an easier way to do this. So instead of using kind of the ratio method, what we can do is actually start off by just dividing it and then cube rooting the scale factor, which might be easier. So, yeah, I believe that would be actually the easier method to do. So in this case, what we can do is say the volume scale factor is just 1587.762 over 58.806. So if we work out what that is quickly, 1587.762 over 58. By the way, the method we were just doing is not wrong by any means, but there we go. Now we get a whole number. I see their tricks. Okay. The reason why I'm saying to do this, so the reason why I'm saying to do that is because it's slightly easier to deal with, right? It's a whole number. But yeah, this method would work, but this is probably easier, which means the height scale factor, or the length, whatever you want to call it, is just the cube root of 27, which is equal to 3. Cool, okay. Now all I need to do is work out the height of prism B. So the way I'll do that is the height is just going to be 43.74 divided by 8.1. Let's do that. So 43.74 over 8.1 gives me 27 over 5, so in other words 5.4 centimeters. So now to go to prism B, I can see it's a smaller prism, right? So I'm going to take that 5.4 and I'm going to divide it by 3. Okay? If I was going to the bigger prism, I'd times by 3. That's the logic, right? I can see visually it's getting smaller, so I should divide, which gives me an answer of 1.8 centimeters. Easy peasy lemon squeezy. All right. So again, using that initial method I started with would not be wrong by any means. By any means, right? It would be 100% correct, but I figured that this would actually be a far quicker method, has nicer numbers in it and everything. Okay, so, oh boy, all right. L, M, and N are points such that it's a straight line. So, okay, what I'm going to do again is I'm going to do a good old-fashioned diagram. Doesn't need to be too accurate. In fact, this isn't going to be accurate at all because if you notice, M's going down when it should be going up because the Y coordinate's bigger. And then it says N is a big fat question mark. Okay, but it does tell me that the ratio of LM to MN is 2 to 3. So what we can do here, and this is probably quite clever, is if we work out the difference in the X coordinates, that's 2 parts, so we can make that 3 parts by timesing by 3 over 2, and that will give me the X coordinates of this. So what I mean by that is the difference in X, let's write it up here, is 4 minus 3, right? So it's 7. Now it tells me that the ratio is 2 to 3. So 2 parts in this equation is equal to 7. So that means 1 part equals 3.5, which means the 3 parts for m to n is 3 times that, which is 10.5? Yeah, 10.5. So what that means is the difference in x coordinates from here to here is 7, which means the difference in x coordinates from m to n must be 10.5, because if you look at the ratio, it's 2 to 3. Okay? So the x coordinate of n is just going to be 4 plus 10.5, which is 14.5. That's the x coord. I hope that makes sense. We're going to do the same thing for the y coordinate. So the difference in y. So it goes from 9, so it starts at, ends up at 9, starts off at 1. So the difference there is 8. So that means 2 parts equals 8. Right, because again, that's what the 2 parts is here. So 1 part equals 4. And because we want to get to 3 parts, right, because that's what it says in the ratio, that equals 12. So that means the y coordinate, again, what this is telling me, right, is the difference in this is going to be 2 parts. The difference in this has to be 3 parts. So all we need to do is do 9 plus 12, which equals 21. So the coordinates for n are 14.5, 21. 4 marks. A lot of 4 markers in this. All right. What's next? Enlarge the shaded shape by a scale factor of -2 with center of enlargement 0. Okay, I actually haven't gone through this on the channel, so this is probably quite an interesting video, interesting question. So what I do is I put an X where the center of enlargement is. Doesn't matter where it is, I put an X there. And here's what I do, is I take each coordinate. So what I do is I look at this point, and all you want to do is ask yourself, how many to the left and how many to the right does it go? So I'm going to basically color code every single point, right? So it goes 1, 2, 3 to the left. And it goes 1, 2 down. Okay? For that one coordinate. And again, you're counting this from the center of enlargement. Okay? So if the center of enlargement was somewhere up here, it just goes down and to the right. That's the whole point of the center of enlargement, right? So now I have to times it by my scale factor. So once I times it by 2, I mean the 2 is easy, right? This becomes 6 and that becomes 4. The minus does something a bit more interesting, okay? So if you just times it by 2, it stays in the same direction. It'll be 6 left, 4 down. But when you times it by a negative, it flips the direction. So instead of 6 left, I'm going to go 6 right, and instead of 4 down, I'm going to go 4 up. So let's do that. And again, I start from the center of enlargement. So the most common mistakes I see is A, people don't count from the center of enlargement, they count from the origin. 2, if it's negative, they forget to flip the direction. 3 is that they don't do these steps from the center of enlargement. So the center of enlargement's here, I'll be going 6 right and 4 up from that point. Okay? So I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Now again, in this case, because the center's 0, 0, we're basically just getting coordinates, right? 6 and 4. So it's nice and easy. You repeat this for every single... Well, you don't actually need every single point. You can kind of work out what it's going to look like just by doing a couple of the points. But I'll do every single point just to make it super clear. So that one is 5 to the left. And again, it's 2 down. So multiply it by 2, that gives me 10. Multiply it by 2, it gives me 4. And because it's negative, instead of left, it goes right. Instead of down, it goes up. So we're going 10 to the right. So 0 goes to 10 to the right, and then 4 up. And you should find that it is upside down afterwards. Let's use orange for the next one. That goes 6 to the left. And it goes 1, 2, 3, 4 down. So again, multiply by 2. Multiply by 2, and then because it's negative, instead of left we're going right, instead of down we're going up. So we go 12 to the right, which is here, 8 up, so 12, 8 is right over there. And you can probably see where the next one's going to go, because you know this length is going to be twice as long, so then all you need to do is draw a point that's twice as long. But again, for the sake of completion, let's do the whole thing. So black is 2 to the left, and it's 4 down. So that means, again, times it by 4. Sorry, times it by 2. And flip the sign. So that goes 4 to the right, 8 up. Here. And now here comes the fun part. He says sarcastically, you draw a straight line using a ruler. And that's it. And you should find if it's negative, it flips upside down as well. And it's on the opposite side. That's completely fine. So if it's negative, here's a few things you can use to check. It should be on the other side of the center of enlargement, and it should be upside down. Okay. Oh boy, Venn diagrams. Shop manager wants to advertise special offers. He asks 100 customers which of type A, B, or C they use, and then they give this information. Okay, so we've probably done these a lot, but I will say 4 marks is a lot, I agree, but it is so easy to lose marks in these questions. So damn easy, especially when you're rushing and you're under pressure. You lose a mark for every number that's wrong or missing or in the wrong place. So you have 4 mistakes. You start off at 4 marks, cool, but then you drop 1 for each one. So what I do is you always start from the middle and work your way out. So here it says 4 uses all types, right? So put a 4 there. And then I tick it off. Okay? The next thing it says, 16 do not use A, B, or C. So that is outside all 3 circles. Boom. 8 use A and B, but not C. Okay, so if I look here, they use A and B, but not C, then that's going to be this point here. 14 use B and C. Now here's where you need to be really careful, because in this part, it specifically said not C, which means we don't count the 4 over here. But in this case, it says 14 use B and C. B and C is going to be this whole overlap here, which includes the 4. So 10 goes here, because 14 in total use B and C. That includes the people that use A as well. Then it says 62 in total use type A, but I can't actually do anything because I have 2 different missing values. So here it says all 20 people who use type C also use at least one of A or B. So basically, in this whole circle here, it should add up to 20, but it says all people who use C use at least one of A and B. So there should be none by themselves, none at all. Which means these 3 numbers here, and again, this number's missing, don't forget, but all 3 of these numbers should add up to 20. So if 10 plus 4 is 14, that means this should be 6. So can you see that all of the numbers inside the C circle add up to 20, which is what it says here. 62 in total use type A. So this number plus these 3 numbers should add up to 62. 8 plus 4 is 12, plus 6 is 18. So we're doing 62 minus 18. Let's be lazy and use a good old-fashioned calculator. 62 minus 18, 44, okay? 44 go in here. Okay, now how do we work out B? Well, in this particular question, and this is what I recommend you do, you need to add up all the numbers you have. It should add up to 100. Anything left needs to go in your empty space. So either it goes outside the Venn diagram, here in this box, or it goes into whatever space is missing. So what we're going to do is we're going to add up all of the numbers that I can see in my diagram. We have 44, we have 8, we have 4, we have 6, we have 10, whoops, we have 0, and we have 16. Everything left over, so 100 minus answer, 12, is what goes in B only. Now again, I want to point this out, is that sometimes they give you all the numbers in the circles, and then they leave it, and people don't work out the number on the outside, right? So all of these would give you the numbers on the inside, and they say, hey, I'm done, cool. But they drop a mark because they haven't worked out the leftover. The final step in any Venn diagram question, anyone at all, is you add up every number in your Venn diagram, and it needs to equal the total. If it doesn't, that means you've either A, done something wrong, or B, there's a missing number that you need to fill in, including the one on the outside. At minimum, there should be a 0 on the outside. It should never ever be blank. It could be 0, but it's not blank. Okay? Okay. I'm sorry for yelling. I'm kidding. One of the customers is chosen at random. Given that he uses A, what's the probability that he also uses B? So we're just looking at this A circle here. Now, how many of these people in A use B? Well, it's these two numbers here, 8 plus 4. So we're going to do 8 plus 4 for our number of people that use B. And how many people use A in total? Well, it does tell me. It says 62. But it's all of these numbers added together. So 8 plus 4 over 62, which is 12 over 62. Which you can simplify, but you don't need to. 6 over 31. By the way, if it doesn't say give your answer in its simplest form, you don't have to simplify. So it's completely fine if you don't. Graph below gives the volume in litres of water in a container t seconds after the water starts to fill the container. Calculate an estimate for the gradient of the graph when t was 17.5. Okay, so first of all, let's work out what 17.5 is. So between 15 and 20, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 in between 15 and 20. So 5 divided by 10 will give me how many each one's worth. So it's 0.5. So it's 15.5, 16, 16.5, 17, 17.5. So we're looking right here. So we're looking at this point on the curve. And it says work out a gradient. Now, if you have a curve like this, what we're going to do is we're going to do a tangent. Everyone's favourite. And they do give you quite a bit of leeway in these questions all the time because, again, that could technically be a tangent, right? Technically speaking. In fact, I think I did that practically perfectly first try. So basically, when they say tangent, what you want is something that looks the same steepness as that part of the graph. And I think that's pretty good. Well, I didn't mean to do that, but okay. I did not mean to do that. But fair enough. But yeah, you just want something that matches. They do give you quite a bit of leeway. And all you're doing is working on the gradient of this line that you have. So I'm going to use the oval triangle here. So it goes from 25. So yeah, let's do the height first, actually. What does the height go up in? I think it goes up in the same thing, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes up in the same thing. Okay, so if I read off the height here, that is about here. So 15.5, 16, 16.5, 17, 17.5, 18. Let's say 18.25 just to be super accurate. Super precise, actually. I don't know about accurate. And the width, it starts off at 5.5, 6, 6.5, 7, 7.5. And it ends up at 25. So 25 minus 7.5. Please? Okay, there we are. 25 minus 7.5 is 17.5. Okay, cool. So the width is 17.5. So the gradient is just the difference in the height divided by that. And they give you, again, quite a bit of leeway in the answer. At least when you have normal ones. So I have noticed in these practice papers, they tend to not give much of a range, which, again, in the real thing they do. 1.04. Okay? And this, in this case, would be litres per second, right? So if I quickly check the mark scheme, I'll be back in 2 seconds with a seamless edit. Okay, so I hope you didn't even notice the cut. But it says here in the mark scheme between 0.9 and 1.2 is the answer. Now it says describe fully what the gradient represents. Now here is a trick that I really love to show people because a lot of students, when they see a question like this, they kind of just turn down. Here's what you can do. This is really cool. You can always say this exact thing. It is the change in y-axis, so volume, per unit x-axis, time. That will always give you the full mark, okay? You can say the change in whatever the y-axis is per unit x-axis. So if this was, let's say, weight and this was meters, like distance, you'd say it's the change in weight per unit distance. Works all the time. Really, really useful. Now, what else could you say? You could also say it's the rate of change of the volume. The reason why we can say rate of change is because it's time on the x-axis. But you don't need to worry about that if you don't want to. Okay, I think we're about halfway through. I'm hoping we're halfway through. The shaded region shown on the diagram is bounded by 4 straight lines. Yeah, I can kind of see those. Find the 4 inequalities. Well, okay, let's start with the straight lines. So this one here is just x equals minus 3. Now if we look, it's to the right of this shape, which means it's going to be greater than. Okay? Now because they're all solid lines, it's greater than equal to. Remember, with inequalities, a solid line is equal to, a dotted line is not equal to. So the first one, and that gives us 1 mark. That's 3. So again, I'll start with the easy one. So again, this one here, that is, I'm going to count that as 6. So that's y equals 6, right? Because again, it's a horizontal line at y equals 6. And it's below it, and it's equal to. So it's y is less than equal to 6. There you go. I've gotten 2 marks already. For some of you, that might be enough, but let's be a little ambitious. We now need to work out these 2 other lines here, which is a bit annoying, but, you know, is what it is. If we can read off some of the information. So for this one, I'm going to call this one equation 1. I'm going to call this one equation 2. And what that'll do is it will just let me kind of, you know, pick it a bit easier. So equation 1, we have y equals mx plus c. I can read off what c is, right? C is just where it crosses the x-axis, the y-axis, which is 6. So this is just equal to 6. That's nice and easy. Now I need to work out the gradient. So what I do is I'm going to make a triangle that's along here, and then along here. So the width of the triangle is 2. The height of the triangle is 6. So it's 6 divided by 2, which is of course 3. So the equation for that line is y is equal to 3x plus 6. And if you notice, it's above that line, right? So it's greater than. So y is greater than equal to 3x plus 6. Now let's do the same with the red line. Well, I call it the red line, line number 2. We still have, again, y equals mx plus c. Now the c we should be able to read off once more. It's halfway between 0 and 2, so that should be 1. And what about m? Well, what we can do is, if we make the triangle from here, right? That's probably not the best one to do, actually. And do it all the way over to here. That makes more sense. Because we want things that are kind of like in the middle that we can quite easily see. So it goes from 2 to minus 3, so that difference is 5. And, okay, I think that should be fine. Is there an easier one? There is an easier one. Let's change that slightly as well. We can get rid of these parts here. We're going to go from this point here to this point because they're both directly on numbers, which makes it a lot easier. So it goes from 2 to minus 6. So that is 8 paces. Paces, sure. And the height goes from 0 to 4 there. So the gradient is just 8 over 4, which is 2. However, because it's going down, I need to make that negative. So we have y is equal to minus, hang on a minute, I did the wrong way around. It's 4 over 8, not 8 over 2. That. So it's 4 over 8, which is a half. And it's negative because it's going down. So minus a half x plus 1. And if you notice, it is above that line. So we're going to say it's greater than equal to. So each of these gives you exactly 1 mark. Not too much work, I suppose, but yeah, that is how I would approach that question, okay? I'll do the easy stuff first just because I want to secure some marks, and it'll make me less depressed. Okay, so we have some functions. I love functions. Okay, so we have 3 functions. F of x is the cube root of x, g of x is 2x plus 3, hx is fg of x. find the inverse function of h. So the first thing we need to do is find out what h is. Now h is just the entire equation, the entire function g, substituted in. So this substituted in for x. Right? So it's going to become the cube root, and where I have x, I'm going to write 2x plus 3. Okay. So now I want to find the inverse function. So I'm going to change h of x to y quickly. We're going to cube both sides, so that becomes y cubed is equal to 2x plus 3. Minus 3 from both sides, we get y cubed minus 3 equals 2x. Half both sides, so we get x is equal to y cubed minus 3 over 2. Now all we do is we replace x with h to the power of minus 1, and we replace y with x. Okay, so yeah, x cubed minus 3 over 2. Alright, that wasn't too bad, I hope. Next question. So with this question we have some iteration, however there is a little bit of a twist. So it tells me the value of k, cool. And it says, find out how many years it takes for the insects in the population to double. You must show how you get your answer. So there's a few different ways to do this. They don't tell me the original number. So one thing you could do is sub in a number, say p is 1, and then see how many times you have to multiply it in order to get p equals 2, right? The other way to do it is kind of a bit more mathematically sound, in the sense that, so again, you can sub in a value. So you can say, you know, let pn equal 1, and then keep subbing in this and just keep pressing equals on your calculator, right? So if I'll show you how that would work, is we would do 1 and then press the equal sign. So that's my answer. Then 1.13 is the constant. So you press equals. So that's 1 time, 2, 3, 4, 5, 6. So it takes 6 years for it to double. Okay? That is one way that you can do it. 100%. The other way that you might see in like mark schemes or online is that each time we're just timesing by 1.13, right? So in the first year, we're doing 1.13. The second year, we're doing 1.13 squared. Third year, 1.13 cubed. Fourth year, 1.13 to the power 4. Blah, blah, blah. So you can do something like this, which in my opinion takes a bit longer. So I would prefer to do the first method that I showed you. But yeah, you can just do it kind of this way. So what you'd do is you'd type in your calculator 1.13, okay. So then if I have it squared, what would happen? Okay, it's this, write down what that is, and then continue going up until you get to eventually 6, which should give you the exact same answer that I just mentioned. So the reason why we waited for it to go up to 2 is because 2 is double 1, right? It now says k actually increases year on year from its value in 1.13 in year 1. How does this affect your answer? Well, if it's increasing, it should get to double faster. So it'll be fewer years to wait. That'll be pretty much the only thing you need to say. Okay, so now we have a cone joined to a hemisphere to make some kind of weird, like upside down ice cream looking thing. The diameter of the base is 7. Diameter of the hemisphere is also 7, of course it is. The total volume of T, which is the whole solid here, is 120 pi. Total height is y. Calculate the value of y. Okay, so this actually isn't too bad. Look at the information that they've given us. They've given us a total volume, and they're saying the height is y. So here is what I'm going to do. Well, the first thing I'm actually going to say is we actually know part of the height. So here we have the diameter, right, is 7. So half that is going to be 6. That's the radius of this shape. Of this shape here. Now, because it's 6, I actually know instantly that that length is also 6. Right? So the height of the cone itself is actually y minus 6 centimeters, because I already have 6 centimeters from the bottom part of the cone, right? Because again, it's the radius, right? Which means it's the actual kind of width of it, so to speak. So I already know what that is. That's nice. And now we're going to use this total volume thing. So how do we work out the total volume? Well, what we do is we take the volume of a cone and we add it to the volume of a sphere. So let's do the cone first. So 1/3 pi. The radius is going to be... Hang on a minute. Did I do something really stupid? I did. What did I do? Sorry, the radius isn't 6. It's 3.5. Not exactly sure what was going through my head, but 3.5 it is, okay? Anyways, that was strange. Times the radius squared, so that's 3.5 squared. Times the height. Now the height of just the cone is y minus 3.5. So we have to leave it like that for now. Plus the volume of a sphere, which is 4 over 3 pi. Radius is 3.5 cubed. But this isn't a sphere, it's a hemisphere. So we need to actually divide that whole thing by 2. And that equals 120 pi. So what we can do first of all is actually get rid of the pi's in everything that we have. And now what I'm going to do is I'm going to kind of times out all of this stuff. So I'm going to do it step by step. So a third times 3.5 squared. So I'm willing to bet this is going to give me a disgusting number, but let's just do it and work it out. Okay, 49 over 12, that's fine. I'm going to do it in a few steps, but you can do this in fewer steps if you so choose. Then we have 4 over 3 times r cubed, which is 3.5 cubed, whoops, cubed, which is that, and then we have to divide it by 2 because I said so. 343 over 12 equals 120. So now what we want to do is expand those brackets. We get 49 over 12 y minus, so we need to do 49 over 12, and we need to times it by 3.5. 343 over 24. Interesting, okay. Plus 343 over 12 equals 120. And let's work out what that is. So 340, oh god, there we are, cool. 343 over 12. I'm going to minus the answer because the answer was that thing here. Leaves me at 343 over 24. So I do not have enough space for this. Let's do it up here. We have 49 over 12y plus 343 over 24 equals 12. Let 120, God. Now move this over to the other side by minusing 343 over 24 from both sides. We get 49 over 12 y equals 120 minus answer. We get 2537 over 24. I'm going to times both sides by y. We get 49y is equal to, so if we times both sides by y, we're actually just going to get 2537 over 2, which means y is equal to 2537 over 98, because I've divided both sides by 49, which means y is equal to, so again I'm going to do that for you. So we have that times by 12 gives me, as I said there, divide by 49, exactly what I said there. And then it says to 3 significant figures, 25.9 centimeters. Good lord. Alright. Hope that makes sense. The diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. Assuming the volume wouldn't change, explain the effect. Well, that's a good question. So, increasing the diameter means that this 3.5 increases. So does this negative. So, actually, it's even easier than this. So this minus 3.5, I took away 3.5 here, right? If that is bigger, then that means the actual height of the shape is going to decrease because it's going to be y minus a bigger number. Right? The other way to look at it is when I rearrange the whole thing, it's going to decrease because we're taking away a bigger number. So height of the shape should decrease. Height decreases. Both of those things would be valid answers. Oh great, 3D trig, everyone's favourite. Okay, so this is a cuboid, which means the opposite sides are going to be the same height and width. Okay, cool. It also means it's symmetrical down the middles and the like diagonals as well. So let's write this out. So A to D is 9. F to D, so this diagonal here, is 13 centimeters. GHF, let's look at that. Where's G? G's here. GH HF. So that is on the flat side itself. That angle here is 49 degrees. So let's have a think about what we need to do. Okay, so this is going to be a bit strange. So because this is 9 centimeters, then this length here, GH, is also 9, right? Because remember, the widths of the cuboid will stay the same everywhere. Now the reason why I'm doing this is I can actually work out what FH is. And because I want to work out what the angle FAH is, so if I draw that triangle out, FAH, how would be the best way to say FA and then to H? Like this. We have AFH. The only thing I can really work out right now is I can work out what the side FH is, because I'm trying to work out what this angle is here. Okay? So the way I can work that out is if I draw this kind of, imagine you're looking down on it, we have a rectangle, sorry, a triangle, FGH, where this angle here is 49 degrees, right? And we also have that this length is 9 centimeters, because again, the width of the cuboid is going to be consistent throughout. So we can use that to work out FH, so using good old-fashioned trigonometry. This is a right angle, because everything is at right angles, because it's a cuboid. So this is the hypotenuse, this is the opposite side, this must be the adjacent. So we have adjacent and hypotenuse, so we're going to use cos. So if cos 49 is equal to adjacent, so 9, over FH, which means FH is equal to 9 over cos 49. So let's try and get our calculator out. 9 over cos 49. Really? Right, because I didn't close that bracket. If you ever see syntax error, generally speaking, you haven't put a closed bracket or there's an empty space. Right? So when I do something like this, if I leave that blank, that's a syntax error. Syntax is just how something is structured. So the structure's wrong. That's 13.7. I'm going to leave it to 1 decimal place. Actually, let's do it 13.72 centimeters. So that's to 2 decimal places, okay? That's that length there for FH. So I now know this length here is 13.72, and this one here. So I need to think about how to work out FA, which, by the way, is just the height of the actual rectangle cuboid thing itself. Okay, and the way that we can work out what the height AF is if you look at this triangle on the front, FAD, this side here is just going to be Pythagoras. So let me draw out what that looks like. They tell me this is 13, they tell me this is 9, so we can use Pythagoras to work out this side. That's going to be square root 13 squared minus 9 squared, which is, again, remember that's because 9 squared plus this squared equals this squared. So if you rearrange that, you get 13 squared minus this squared, then you have to square root it to get your answer. So square root 13 squared minus 9 squared gives me 2 root 22. I'm going to leave it as 2 root 22 for now, because that gives me a more precise answer. And that is going to be this side here. So to work out theta, we have, again, this is a right angle, so this is the hypotenuse. This is the opposite side, this is the adjacent. So we have opposite and adjacent, so it's going to be tan. So tan theta is equal to 2 root 2, 22 even, over 13.72. And that is going to be, so theta equals, and by the way, this is actually the angle FAH. So we're actually done after this. So inverse tan, we get 2 root 22, 2 root 22 over 13.72, which is 34.4 degrees. And wait, hang on a minute. And just before we go on to the last step, I actually realised that we're looking for this angle here for theta. So I've actually labelled this slightly incorrectly. So we get rid of that. So this here is the hypotenuse. That is the opposite, and that's the adjacent. And this was 13.72. I don't know why I rubbed that out. But yeah, we have tan theta equals opposite over adjacent. So that's going to be 13.72 over 2 root 22. Okay, so forget about this. And that's going to be tan inverse, so let's quickly do that. here. So yeah, I misread the question ever so slightly. 2 root 22. 55.6, so to the nearest degree is 56 degrees. So yeah, essentially if I just quickly edit this slightly, just to make it a bit more clear, is the mistake I made is I read FAH, but for some reason I put FHA instead. That's where our actual angle is. So we're going to be doing 13.72 divided by 2 root 22. Like that. Okay? Perfectamundo. And algebraically, the set of values for which this. Okay. So what I would do here is if I quickly do this section here, that's, if you factorize that, that's just the difference of two squares greater than 0. So what we need to do now is actually work out, so the solutions here are x is minus 7 and x is plus 7. Now we need to work out what way the inequality looks. So if we sketch this graph out, we have minus 7 over here, we have 7 over here, something like that. Now if we're looking for the values that are above 0, that is these values over here. So in other words, my solutions there are going to be x is less than minus 7 and x is greater than 7. Okay? And to do the same thing for this, we just need to work out the two solutions. I don't think you can factorize that. Actually, you probably can. You can definitely factorize that. But if you want, you can just use the quadratic formula, which, you know, I always find to be a bit preferable. So we have calculator minus b, so minus open bracket minus 31. That says 21. 21. Plus minus, so I'm going to do the plus first. B squared, so that's minus 31 squared. I press 21 again, my goodness. It's a good thing I'm checking every time I do something. Minus 4. A is 5. C is minus 72. Over 2 times A, which is 5. So that gives me one value is 8, so called, this was actually factorizable. Or x is equal to minus 9 over 5. Let's call it minus 1.8 to make it a bit easier. So again, I'm going to do the same thing. You sketch up the quadratic. So again, it's going to look something like this, where this is minus 1.8 and this is 8. We're looking for the values where it's greater than 0. So that's these values here and these values here, which was when it's less than minus 1.8 and greater than 8. So now what we need to do is find this full set of values. So how do I do that? Well, here's what I do. I'm going to draw out a number line, okay? And believe it or not, we even use these in A-level when it comes to questions like this, because it makes it completely bulletproof, your answer. 2, 3, 4, 5. Cool, right? Now if I draw all of these inequalities, we have x is less than minus 7. So what we do is we have one that's like this, and it's going all the way that way. We have x is greater than 7, so we have one that's here, going all the way that way. We have x is less than minus 1.8, so that'll be somewhere along here. So that's going to be that. And x is greater than 8, it's going to be like this. What we're looking for is the overlaps. So this is where both of these are true, right? So in other words, they're both true at less than minus 7. So if x is less than minus 7, comma, and they're both true over here when x is greater than 8. So that would be our two sets of values. Again, I'd recommend just using the good old-fashioned, let's say timeline, number line, which will make your life a lot easier when it comes to something like this. Describe fully the transformation. Well, first of all, if you have a look, they're both the same shape. They haven't changed size. They're not reflected. They're in the same orientation, which means it's going to be a translation, which gives you 1 mark. And then you have to say by what vector. So what I do is I pick a corner, let's say this one, and I can tell that that goes to that corner here. So how far to the right does it go? It goes 1, 2, 3, 4, 5 to the right. That is the top number. If it goes left, you make it negative. And how far up or down does it go? Well, it goes down, so it's going to be negative 1, 2, 3, 4, 5, 6. That's the second mark. Not too bad, right? We have another function. Okay, oh, this one's not too bad. G of 16, that means all you need to do is take the value of 16 and you plug it into x here. So G of 16 is just equal to, and again, you can do this all on your calculator, but I'm going to show you the actual full working just to make sure you understand. Instead of x, I'm literally just writing the number 16 in brackets, and you just shove that all in your calculator and you are done deezy. And that's 2 multiplied by 16 minus 5, which gives me an answer of 3. That's nice, I suppose. Then it says find h g of inverse of x. So what that means is we're finding the inverse function of g and we're subbing it into h. So first thing we need to do is g of x looks like this. So what I'm going to do is instead of g, I'm going to write y. And I'm just going to rearrange for x. So cube both sides. In fact, this looks really familiar to the last question, the other function question. Add 5 to both sides. Boom. Divide both sides by 2. X equal to y cubed plus 5 over 2. So it means my inverse function for g looks like this. Replace x with g minus 1 of x. Replace y with x. And now it says hg of x. So now we're going to sub in the entire thing for g into h. So that's 1 over x cubed plus 5 over 2. Now, for those of you that might be a bit switched on, a bit more kind of in depth, all it does is actually just flips the fraction. That's just taking the reciprocal. For those of you that aren't aware, this would just be 1 divided by x cubed plus 5 over 2. Keep flip change, you keep the first fraction the same, so that's just 1 over 1. Change it to a times and make that 2 over x cubed plus 5. And when you multiply that, you will get 2 over x cubed plus 5. So either way you want to look at that, you get 2 over x cubed plus 5. Circles, everyone's favourite. Oh, it's a tangent question. Good. That's actually what someone's actually asked me for in the comments. So yeah, let's get into it. So these tend to be quite tricky questions. I would recommend always drawing a little diagram. So, although they haven't really given me much space, which is kind of annoying, let's draw it up here instead then. So, with your circles, Jesus Christ, they always have this kind of equation. So if you ever see x squared plus y squared, you can kind of guarantee that it is indeed a circle. Now the 12.25, actually, I don't really care about it that much. What we do care about is that the circle is going to be on the centre. And let's say the coordinates of P are here, 2.1, 2.8. And we're looking for a tangent that does something similar to, oh god. Alright, let's move that slightly. There we are, something similar to that, right? The actual mechanics of it don't matter. So how do you work it out? Well, the good thing about this is that it's always the same steps. And these are 4-mark questions. Always the same bloody steps. All you need to do is remember your circle theorem, which says that the radius meets the tangent at 90 degrees. In other words, the radius and the tangent are perpendicular to each other. So, if I work out the gradient of the radius, so I'm going to call that MR for gradient radius, which is just going to be the change in y, which is 2.8 minus 0, because it's at its centre, over 2.1 minus 0. That'll be it. We can do the negative reciprocal, so I'm just going to do 2.8 divided by 2.1 quickly. 4 over 3, that's a nice, easy fraction to deal with. Then, because the tangent is perpendicular to it, we can flip the fraction to make it 3/4 and make it negative to find the gradient of the tangent. If you look at my diagram, the tangent is going down, negative does kind of make sense. So my equation for the tangent so far is minus 3/4 x plus c, because remember the equation that I want you to have burned into your memories for years to come is y equals mx plus c. Now how do we work out plus c? Because remember we do need to work out what c is. It says c is an integer. Well, what we need to do is sub in our coordinates. We know that x is 2.1, we know y is 2.8. So if 2.8 is equal to negative 3/4 of 2.1 plus c. So I'm going to add that whole thing to both sides and just use a calculator to work out what my value is. Now I'm expecting to get a fraction. This is a good thing, believe it or not. 2.8 plus 3/4, so that's 0.75. I'm just too lazy to press the fraction button on my calculator. 35/8. Good, this is really good, believe it or not, again. So my equation is now y is equal to -3/4 x plus 35/8. Now if I have a look at the form it's giving me, it's ax plus by equals the integer. So I'm going to move the x to the other side. So we get 3/4 x plus y equals 35/8. But if you look, all of my values should be integers, and if you notice, I actually don't have a b in this case. So I need to make these integers, and if you notice, we have a 4 and an 8. So I need to multiply through by the biggest denominator, which is 8. So if I do that, well, actually I'll use a calculator just to make sure you guys see exactly what I'm doing. The 3/4 times 8 is just going to be 6. So 6x. And don't forget we've multiplied y by 8, right? We've times the whole thing by 8. So that'd be 8y equals 35/8 times 8, which is going to be 35, which is actually our final answer. Just make sure you times everything by 8. Okay, every single term, not just left and right side. I'm talking about every single term in those sides. I think we've got 2 more questions now. Ooh, ratios. I like ratios. Not really. The ratio of Marta's hourly pay to Khaled's hourly pay is 6:5. So let's do M to K, 6:5. Both of them get an increase of £1.50 in their hourly pay. Okay, so we can plus £1.50. Okay. The ratio of hourlies is now 13:11. Okay. Here's the way I would do this kind of question. After the change, before the change. Okay. In the first sense, I have no idea what their kind of hourly rate is, right? So what I'm going to do is, in this case here, if we call the hourly rate x, for instance, right, then what we can do is we can relate that to make 13/11. We can say that that is 6x to 5x is equal to that. However, it's actually slightly more complicated than that. Let me just move this over slightly. It's plus that 1.5. So where did I get the x from? Well, the x just comes from, I don't know what their hourly rate was before. X is the hourly pay before the increase. Okay? And we've added 1.5 to it. And now the ratio is 13:11. Now what you can do is you can actually write this as a fraction immediately. You can say 6x plus 1.5 over 5x plus 1.5 equals 13/11. That's the useful thing about ratios, okay? So again, we've just changed it into a kind of calculation here. If you want to see like a more rigorous proof of that, then 6 to 5 becomes a ratio of 6/11 x for Martha, and it would be 5/11 x for Khaled. Marta, not Martha, sorry. So how do I solve this? Well, what I'm going to do is I'm going to times by both denominators, times by 11 and times by 5x plus 1.5. What that's going to do is it gets rid of the denominator on both sides. So I'm going to get rid of the 5x plus 1.5, then times by 11. So we have 11, 6x plus 1.5 equals 13. The 11 goes away, but then we have 5x plus 1.5 on this side. Expand the brackets, we get 66x plus, what would that be? Let's just use a calculator, why not? 11 times 1.5. 33/2, so that's what? 16.5, yeah. 16.5 equals 13 times 5, which would be 65x plus, I don't know what 13 times 1.5 is. Please, there we are. Okay, 13 times 1.5, which is 19.5. Cool. Let's move the x's to the left and the numbers to the right. So we get 66x minus 65x, which is just x. We get 19.5 minus 16.5, which is 3. So, okay. Now keep in mind that x is the kind of individual part here. So if we want the hourly pay for Marta and Khalid, Marta has 6x, right? So if I get rid of this just so we have some space. X is basically how much each part is worth. So Marta has 6 of those parts, so 6 times 3. Her hourly rate was £18 an hour. And Khalid gets 5 of those parts. So that's 5 times 3, which is £15 an hour. Okay? So I hope that makes sense. So just as a recap, X is how much one part is worth into this. So it's basically 1/11 of the total. And yeah, once we work that out, we know that Marta has 6 parts, Khalid has 5. Okay, so a race is measured to have a distance of 10.6 kilometers to the nearest point 1. Sam runs it in 31 minutes 48 seconds, correct to the nearest second. Average speed is v. By considering bounds, calculate the value of v to a suitable degree of accuracy. So you must show all of your working out. So here's what we need to do. What we need to do is basically work out the smallest value it can be, the biggest value it can be, and then find the middle of those two values. So let's say for the smallest v, right? To work out speed, you just do distance over time. So if I want v to be as small as possible, what I need to do is I need to make distance as small as possible and time as big as possible. So the distance is going to be 10.55 kilometers, right? Because you're going to minus 0.05 from it. And the time is going to be 48.5, because we want to make it as big as possible. Okay, so that's minutes and that's seconds. So I wrote that horribly. 31 minutes and 48.5 seconds. So now what we need to do is actually change these into the appropriate units. So we have kilometers here, that's good. I'm going to get rid of this because again it was ugly as hell. To change that into, we need to change it all into minutes. So I'm going to change this, divide it by 60. And that will give me how many minutes that is. So 48.5 divided by 60. And then I'm going to add it to 31. So in total I have this many minutes, right? So to work out the hourly rate, I'm going to divide that whole thing by 60. And I get that many hours. 3817 over 7,200 hours. So my speed, the smallest value for v, is distance 10.55 over 3817 over 7,200, or just over the answer button, which is what I would recommend you do. So we get 10.55 divided by ANS, which gives me 19.9. Okay, I don't really need to make it more accurate than that. I'm just going to leave it as 19.9 kilometers per hour, which is actually pretty fast. Now for the biggest value possible, and it says to a suitable degree of accuracy, by the way. So anyways, biggest value. What we want is we want the biggest part of D, and we want this to be smallest. Now the reason why is because for us to get the biggest speed, right, think about it. This number on the top has to be as big as possible. This number on the bottom has to be as small as possible, okay? So let's do it. The biggest distance would be 10.65, right? By the way, there is another way to lay this out where you basically write down the bounds for the distance like this. And you write down the bounds for the time as well. And then you can use it there if it's easier for you to visualize. And for the time, we're going to have still 31 minutes. But we want the time to be as small as possible. So that's 47.5 seconds. We're going to do the same thing to work that out in hours. So we have 47.5 over 60. That gives me that little piece in minutes, so it's 0.79 minutes. Add it on to the 31 minutes we had originally. Divide that by 60. So we have the total number of minutes divided by 60. That gives me the number of hours. 63 over 1440 hours. Yeah? So again, speed is just going to equal distance over time. So that's going to be 10.65 divided by answer gives me 20 point. Let's call it 20.1. Actually, I'll write out a few more decimal places. 996. So now we know that the values for the speed are between 19.9, right? The speed, and then 20.0996. Blah blah, right? So the question is, what is our value of speed to a suitable degree of accuracy? In fact, let's call that V instead of S because that's what the answer is. Well, all I want to do is round it until they're the same number. So to the same number, that would be 20 kilometers per hour to two significant figures. Because if I round this all to two significant figures, I get the same number, which is what they mean by to a suitable degree of accuracy. It's something you have to do in science as well, and you're doing A-level as well. But that's to two significant figures. 5 marks. So you get a mark for the correct value, a mark for the correct rounding. So you have to put two significant figures. You have to. And you get 3 more marks for doing this. Hopefully that makes sense. That's a pretty tricky question. And let's have a look-see. So 21. Okay, so we have this graph. On the graph, draw that. I was reading the wrong thing. So f of minus x, all you're doing, right, is it's a reflection in y. And let's have a think about why. That wasn't a pun, but let's have a think about why that is the case. Well, this minus x, it affects the x coordinates, and what it does is it times all of them by -1. So any negative coordinates will become positive, and any positive become negative. So in other words, it's a reflection in y. So if we look here, that will become over here. That will become here. That will become. That's 5 plus. 1, 2, 3, 4, 5. Cool. So then all you're going to do is draw the exact same shape. Yeah, not bad. Okay. This question. Okay, so we have tan x graph, cool. And it tells me that the tan x graph is translated to give the graph of y equals g of x, where q now moves to point R, where R has coordinates 90 minus 5. Okay, cool. So, first of all, we should work at the coordinates of q here. Well, the y coordinate's obvious, it's 0. But we need to know what the x coordinate is. Well, with the tan graph, the first asymptote is at 90, and then every 180 degrees. So that's 270, and that would be 540 degrees. And midway between that are these points of 0. So this would be, in this case, it's 0, right? And then you're just adding 90 degrees to find out what each of these are. The reason why I'm adding 90 degrees is because if there's a difference of 180 between these values, there'd be a difference of half of 180, so 90 between these. So 270, that would be 360. Okay? Now it says that it becomes these coordinates. So let's write out our equation. Okay? So g of x in terms of x. So what we're going to do, how do we write that? Let's do g of x is equal to tan x. And then it's going to have some stuff around it, right? So the first one, the easiest bit, is probably this -5. All they've done is subtracted 5 from y. So all you're going to do is outside the brackets put a -5. 1 mark, done. Now, how do I make 360 into 90? Well, I subtract 270, right? Now, the thing is, I don't put negative 270 in here. Because remember, when it's inside the brackets, it does the opposite of what it says. So, you're right, I am subtracting 270 to go from 360 to 90, right? But I need to make it plus so that it actually does the negative. And that would be your final answer. Okay. So on the grid, so we have the front elevation. So the view from the front is this kind of weird shape here. And then it gives us the plan, so top-down look. And it says, if you looked at it from the front, the arrow, well, not the front, sorry, but from the side, what would it look like? Well, what you're going to have is you're going to have, essentially it's going to look like a rectangle, right? And the question is, how wide is the rectangle? It's 3 squares wide. So from the front, it's going to be 3 squares wide. So we're going to put a 3 square light thing here. Now, how tall is it? Well, it's going to be, well, or how long, right? It's going to be 1, 2, 3, 4, 5, 6, 7 high, right? Yes. If you're looking at it from the... Actually, no, my bad. If you're looking at it from this side, you're going to see the width and you're going to see the height. So the height would be 1, 2, 3, 4, 5. So it would actually be 5 you'd see from the front. 1, 2, 3, 4, 5. Just draw that rectangle out first. And the marking on this is very strange. It's only 2 marks. So you get 1 mark for the actual correct dimensions, which is what I've got. I've got 3 squares wide, 5 tall. So that's good. Now we have to think about what we'd actually see. Well, if we have a look here, you need to draw a line every time there's a change in height, right? So as you can see here, 3 squares in, we have a change in height. That's why there's a solid line here. And then there's no other change in like height. And by that I mean like a sharp change. It's like a step. In this case, if we look from the side, 1 block up, I have a line because it changes height, right? Because as you can see, it goes to a diagonal. So we have like a step. We have another one of those in the last kind of 4 parts, right? So we have this sharp decrease 3 squares back. So that's actually 1. We have 2, 3. So after 3 squares, we're going to have a line too, like this. Because it changes and then continues. That is what you need to draw. By the way, in mark schemes, you sometimes see this dotted line, right? It's not necessary. Not necessary at all. That's the end of the paper. Good Lord, that was quite a beefy one. I hope you guys enjoyed. Again, I'm going to leave the link to this in the description so you can have a go at it yourself. But other than that, I hope your revision goes well and I hope you have a great day.